example 10, sketch the curve y equal to x plus 1 on x. So we'll follow the steps. Step 1, we let x equal to 0 to find where the curve crosses the y-axis. However, we know that we can't let x equal to 0 because y is then undefined. So we can state that the curve does not cross the x-axis, y-axis. Does not cross the y-axis because we can't let x equal to 0. Step 2, we want to find the behavior of y as x approaches plus or minus infinity. As x approaches plus infinity, y 1 on x, the 1 on x term becomes 0 because 1 on a big number is 0, so y approaches x. As x approaches minus infinity, y still approaches x because 1 on x is a 0, or 1 on x approaches 0. Step 3, we want to determine any asymptotes. Now we know that to determine the asymptotes, we look at values of x which makes y undefined. So clearly x equal to 0 makes y undefined. So let's see what happens as when x is a small positive number, then y is a small positive number plus 1 on a small positive number, and this 1 on epsilon is a big number because epsilon is a small number. So y approaches positive infinity as when x is slightly positive. When x is slightly negative, then y is minus epsilon plus 1 on minus epsilon. So 1 on minus epsilon is a very big negative number, so y approaches minus infinity when x is slightly negative. So step 4, we need to determine stationary points. So we have y equal to x plus 1 on x. We can write y in a more convenient form for differentiation by writing x plus x raised to the power minus 1. So let's differentiate y to obtain the stationary points. Derivative of x is 1. Derivative of x to the minus 1 is minus x raised to the power minus 2. So at stationary points, dy dx is equal to 0. Therefore, we let 1 minus x to the minus 2 equal to 0. So we have x raised to the power minus 2 equal to 1. Or, in other words, 1 on x squared is equal to 1, which implies x squared is equal to 1. So solutions for x squared equal to 1, well, this implies x is either plus or minus 1. So we have stationary points at x equal to +1 and -1. So let's draw the values of x below the line, dy dx above the line. At x equal to -1, dy dx is 0. At x equal to 1, dy dx is 0. Okay, now let's determine the, the, the value of dy dx when x is less than -1. So when substitute a number less than -1, for instance -2, if we do that, we will obtain a positive value for dy dx. So dy dx is positive. If you substitute a value slightly above -1, we will obtain a negative value for dy dx. So if you substitute a number slightly above -1, we will obtain a negative value. If we substitute a value slightly above 1 in this expression for dy dx, we will obtain a positive value. So clearly at -1, the gradient is going to be, well, for values of x slightly less than -1, is going to be, gradient is going to be positive. At -1, the gradient is 0. For values of x slightly more than -1, the gradient is negative, so that's going to be a maximum. Likewise, the stationary point at 1 is a minimum, because the gradient goes from negative to 0 to positive.